Hello everyone, this will be an introductory video to probability theory. The multiplication principle has numerous applications in problems that require the viewer to calculate a probability. We demonstrate this with an easy example. The first question is what is the probability of getting a 6 when throwing a fair dice? The possible outcomes of throwing a dice are 6, and they are all equally likely to happen. And since our desired outcome is one of them, the probability is 1/6. But what is the probability of getting a 6 twice when throwing a dice? The probability of getting 6 in each dice is 1/6, so due to the multiplication principle, the final answer is 1 divided by 36. However, sometimes the multiplication principle alone is not enough to calculate our desired probabilities. There are cases where we shall consider what is called the complementary probability. Let's say that the probability of one event to happen is Q, and the probability of this event not happening is R. Then it is obvious that the sum of these probabilities must be equal to 1, so we have that Q plus R is equal to 1. We demonstrate the use of the complementary probability with the following example. An experiment has a probability of 16% to be successful after a try. Each try is equally likely to be successful. And the question is, what is the probability of this experiment to have been successful at least once after 4 tries? The truth is, we cannot compute the desired probability at once. We first have to calculate its complementary probability, which corresponds to the situation where the experiment fails each of the 4 times. The probability of the experiment being successful at least once in these 4 tries, plus the probability of the experiment failing in each of these 4 tries, sums up to 1. So we want to solve for the green probability, but first we will have to find out the red probability. The probability of the experiment failing after a try is equal to 1 minus 0.16, and that is equal to 0.84. So the red probability, due to the multiplication principle, is equal to the purple probability raised to the 4th power, and that is almost equal to 0.5. Thus, all we have to do now is subtract this probability from 1 to get the final answer, which is 50%. In the next example, we have a pedigree and we study a trait that is inherited in an autosomal recessive way. The question is, what is the probability that the person 3.1 exhibits the trait? So we see that people 2.1 and 2.5 exhibit the trait, thus their genotype must be small case a, small case a. This means that all the people from the first generation have small case a in their genotype. However, none of them exhibits the trait, thus their final genotype must be capital A, small case a. Okay, now we construct a Punnett square for the possible genotypes of person 2.2. Both of their parents have capital A, small case a as a genotype. Since this person does not exhibit the trait, they have a 1/3 chance of being capital A, and a 2/3 chance of being capital A, small case a. The exact same goes for the person 2.3, since they have the same Punnett square as person 2.2. So we have 1/3 chance of being capital A, and 2/3 chance of being capital A, small case a. In order for 3.1 to exhibit the trait, they must have small case a as a genotype. So both of their parents must be capital A, small case a. The probability of this to occur is 2/3 multiplied by 2/3. Finally, we construct the Punnett square for the person 3.1. We see that there is a 1/4 chance of them exhibiting the trait if their parents both have the capital A, small case a genotype. So due to the multiplication principle, the final answer is 2/3 multiplied by 2/3 multiplied by 1/4. And the final answer is 1 divided by 9. And that's it for today. In the next video, we will talk about the inclusion-exclusion principle.